everyone, and welcome to the Temporal 3 podcast. Today, I am joined by my co-host, Mr. Charles Olner, and my
Good day.
good day, and my other co-host, Mr. Chris Godwin.
Hey everyone.
So, one of the things I'd like to talk about is motivating your employees to get NICET certified. And this is something that we've had some experience with in working with our customers, and sometimes that people struggle with. So, Chris, have you seen students that were in class that did not necessarily feel motivated by their employer to seek NICET certification?
Yeah, there's been quite a few of them. They just for whatever reason they've been told they got to get the NICET certification and not explain the why they're having to get it, whether it's required by the state of jurisdiction or anything like that. And they sit in class and a lot of times it just I have to do this. And it's one of those things that just kind of give some motivation behind it. I've heard of companies that they offer you this much amount of raise for getting a level and things like that. And I thought that was a great idea. Charles, anything on your end? You heard anything like that?
Yeah, I've got a couple of observations on that. I've seen several companies who offer pay incentives for getting NICET certified, but really it boils down to the individual, I think. The individual has to have that drive to get certified, to really push through it. In our industry, as we all know, a lot of our folks haven't taken a test of any kind for many years, and there's a fear factor involved in that. They're afraid of taking the NICET test and failing. So there's kind of more money, fear. Which one's going to win? Bryan?
Yeah, unfortunately so. And I think that sometimes this is a discussion that we have with people. And I think number one, the people in the class, something that we remind them and something that people need to remember about NICET certification. You both hit it on the head. It is an individual certification, not a company certification. So it follows the individual. It is definitely to the individual's benefit to get NICET certified. It makes them more valuable. As I like to say, the more acronyms you have after the end of your name, the better off you are, the more marketable you are. But I've also seen, as both you guys have said, that sometimes the employer doesn't necessarily frame it in a way that the technician understands why they need NICET certification. And it really has to revolve around the benefit to the individual and helping them understand that. We can do that to a degree, but it also leaves it to the employers to do it to a degree as well. Why is it important for the company? Charles, have you seen companies that have utilized NICET certification as a method of marketing?
Absolutely. And for certain types of projects, it's really important that the company be able to demonstrate technicians who have that NICET certification. So project managers, the smart ones, include that in their presentations. Hey, my techs have this certification, and that sets us at a level above your average company.
Absolutely. Chris, you and I have talked about how some people put it on their website, and I love seeing it on the website, how they support NICET certification, and our techs are NICET certified, and it creates a higher level of competency and at least I don't want to call it an illusion, but a perceived higher level of competency of the organization if they promote NICET certification. Would you agree?
Yeah, absolutely. I'd agree with that. Looking at the NICET certification, it's going the extra steps, especially in places where you might not necessarily need it. Uh, in Las Vegas, you don't necessarily need it to do work, but if you have it, it's an added benefit. It definitely is something that brings a little bit more to the technician and also the companies that have their technicians get that certification. And it takes it just that little bit step further. And I don't want to say that it brings about standardization because that's not at all what it does, but it gives potential customers that ability to look and say they've gone that extra step. They have this additional information. They have this by doing and getting the certification, it brings more to the table. And that's one of the things that a lot of employers are not necessarily really good at bringing to the employees and having them understand it. This brings more.
Well, Bryan, it's I would use the term demonstration of competency.
Mhm.
Our industry is code driven and NICET is really focused on the codes.
Right.
Folks who have NICET certification and companies that can demonstrate that,
Mhm.
they have a heightened sense of the code requirements. And as we all know, systems that are designed and installed in compliance with the codes, those buildings just don't have deadly fires. They
Right.
just don't.
Very true. Very true. Well, guys, next topic on the agenda today is NFPA 72, our favorite code as fire alarm geeks, as we all are. And I'd like to talk a little bit about Chapter 12, classes of circuits. This is a topic that we often discuss with our students in our fire alarm design class, in our NICET class, in our fire alarm INT class. It is a category that I find that a lot of people don't necessarily understand a lot of, but also we want to kind of educate that there's just more than one type of circuit. Now, the thing about chapter 12 about the classes of circuits, the classes that they use are based on performance under abnormal conditions. So it isn't necessarily about how the circuit is wired. Some of the circuits do have specific wiring requirements. It is more about how the circuit will perform under those abnormal conditions. So first up, let's start alphabetically. Class A. Charles, talk to us about Class A.
Well, Class A circuits are a higher level of performance in terms of how the circuit reacts to abnormal conditions. Class A circuits are not required to be installed by any code. Typically, Class A circuits are required for projects that have a higher degree of reliability requirement. You might see it from an insurance agency. It's possible a government requirement, a government project might have a Class A requirement. Most fire alarm panels, in fact, I can't think of any really that don't have the capability of Class A. They're all set up to do Class A in one form or another, um, but it's not frequently used.
Yep. Definitely much less common. And one thing about Class A, I mentioned that the code generally doesn't dictate wiring, but that in this case it actually does. It talks about a requirement for a redundant path. So with Class A, the whole part of Class A performance is that redundant path, the return path wiring. And that's what makes Class A capable of operating past that single open. Chris, what are your thoughts on Class B?
Well, I working from the field, most systems are going to be Class B, and there's no redundant path. Everything stops at the one fault. And for a majority of your systems that are going to be used out in the field, this is the perfect method. This is the easiest way to go about it. It's pretty cost effective because there's no return path going back to the panel. It's just outgoing and everything. And majority of your fire alarm systems, this is what technicians know when we talk about how is it wired. It's wired Class B. It's just outgoing paths, and that's generally how most systems are going to be done. Now, as Charles mentioned, you are going to have some that Class A is going to be utilized, and you're going to be looking far and few between though when you look to the differences of how often Class A is used versus Class B is generally what's always done out in the field.
And the thing
Well,
about
and
Class B, again, no redundant path on that one. So basically, you have an open, anything past that open doesn't work. But since
Oh,
fire
right
alarm
there.
circuits are supervised, at least we're going to get a trouble signal and we'll know about the condition. But yeah, much more common for Class B. You would think that Class A, being higher performance, would be more common, but Class B is the most common. So Class C has multiple pathways, and this does not specify, code doesn't specify how these pathways are configured. Rather, it specifies that communications or the pathway itself, I'm sorry, is supervised by end to end communication. The pathways themselves are not supervised. And a common example of Class C is cellular or IP. Think about it. If you have a cellular communicator or an IP communicator, do you supervise the internet? Do you supervise the cell towers? No. You just supervise the signal getting from point A to point B. And if it doesn't get there, you have an indication locally and you have an indication at the monitoring station at some point as well that, hey, I'm not getting the signal, whatever the time period is, depending on how many pathways there are. Charles, what about Class D?
Class D is fail safe. In the event that we have some sort of an issue, we get an operation of the circuit the way it's supposed to. Class D circuits most commonly are probably going to be door holders in fire alarm systems. So that's where we'll see that most commonly used, I expect. Bryan, what's your experience?
Absolutely. The big D there, door holders, sometimes duct detectors as well. Anywhere that we have a circuit, and that fail safe is the key part of it here. That basically by fail safe, we means that it performs its intended operation when the circuit is cut, basically. So the pathway itself is not supervised. And most common example for Class D is an emergency control function, which Charles said could be a door holder, could be releasing the electrically locked doors, could be a duct detector, variety of applications for Class D. How about Class E, Chris?
Class E, you're probably not going to see too many Class E circuits out in the field, as with from the fire alarm perspective. We usually see them when you have two different panels within 20 feet of each other, trying to have interconnection between them. More or less, where you are going to see that more often, wireless keyboards to the monitor, wireless mouse to the monitor, things like that. So from a perspective of fire alarm, we don't really use Class E as much. It's not going to be something that is frequently seen out in the field.
That lack of supervision is definitely an issue, and that's why you don't see it. But there are certain components that are non-critical, like a keyboard or a mouse or something connecting to the panel that doesn't require supervision because if it fails, panel still works. Class N is Ethernet. This is one of the newer ones in the code, and we're starting to see more and more Ethernet in fire alarm. Now, I want to differentiate with Class N for Ethernet. This isn't IP communicators, which actually use Ethernet to go to the router. This is actually Ethernet within the fire alarm system itself. And Class N, because Ethernet itself by nature is not a supervised method of communication, what it requires is redundant Ethernet communication between devices that are connecting two or more, between equipment connecting two or more devices. So commonly, this is switches, for example. So what we'll have is dual Ethernet connections coming out of the panel to the switch and then going to the individual endpoint devices. Then we'll only have one Ethernet connection. And this is all verified by end-to-end communication similar to Class C. Charles, what about Class X?
Class X is Class A on steroids.
Yes.
Class X has even a higher level of performance than a Class A does. One thing that's common with Class X are circuit isolators. You'll see those used in Class X circuits here in the United States. So that's a key indicator that it's something more than just a Class A circuit.
And I think pretty much Class X is going to be SLCs, addressable circuits. I haven't seen conventional circuits that have isolators on them. So generally, it's going to be a Class A SLC, or as Charles likes to say, Class A on steroids. I think that's a great explanation of it. And those fault isolators per device, do you guys anticipate they add significantly to the cost?
Every device having one?
Yep.
No.
So
No.
Charles mentioned at the beginning how rare Class A is, and Class X would be A on steroids, so it'd be even less common than Class A. So you're talking definitely very high-end applications or applications where failure is not an option type of thing. So last thing I'd like to talk about today, guys, is our question from the field, and this one involves using NFPA 70, Chapter 9, Table 8, which is conductor properties. Chris, do you find our students sometimes struggle with using this table for the first time?
I would say yes. There are factors that you've got to understand about the table ahead of time in order to use it appropriately. And one of those big factors, after you get done looking at the factors of the cable itself, is there's not a clear, like 100% clear, here's the distance of the circuit that we're giving you the information about. And it's having to understand the table a little bit more effectively to get to that point of, oh, everything's measured per 1,000 feet. And that is what a lot of students' biggest question: how do you know it's 1,000 feet? How do you know it's 1,000 feet?
Charles, what about from the field? Where does Chapter 9, Table 8 come into play? What part of fire alarm systems are we using that in?
Well, first of all, I have to address two things. This table is difficult to use after the 10,000th time you look at it, not just the first time you look at it.
True.
Secondly, it's called conductor properties. In normal language, that's wire resistance. It means wire resistance, people. That's what
Yep.
we're talking about with this table. Conductor properties means wire resistance.
Right.
So, where do we use this? Well, we use it for voltage drop calculations primarily with NAC circuits. That's the big focal point of wire resistance. It comes into play with SLCs too, to a degree, but those are less critical than the NAC circuits. So that's the real application of it. And voltage drop calculations can get a little complicated. Bryan, do we have training available on that?
Absolutely, we do. That is a topic of discussion in our NICET training and our fire alarm systems training and our some of our 2-hour NICET prep programs. Multiple programs that discuss this because it is really, really important. And in the real world, we know that a lot of times the design program does this. We click a button in the design program, FireCAD, AlarmCAD does all the work for us. We don't have those programs in the NICET exam, so we really need to learn how to do this and how to navigate this table.
And if you don't know this table exists or where it is, doing a voltage drop calculation on your NICET test becomes virtually impossible.
Yep, absolutely.
Conductor properties means resistance.
Yep. Chris, do we have a recommended procedure for using this table that we talk about in our class?
Yeah, 100%. What we look at is being able to identify what the gauge of cable is. From there, you have two for each, 218, 16s, and so on. Your top one is solid, your bottom one is stranded. On the table, it says quantity. Top has a 1, bottom has a 7. That's how many strands are in the jacket. From there, move over. Is it coated or is it uncoated? Uncoded's a little bit more resistance, but that's how you're going to read the table. Ohms per KFT. The K is kilo feet, 1,000 feet. And that is how we teach it. Here's the information about the cable. Table gives us those values based off of 1,000 feet. KFT is that.
And you fellows mentioned earlier, Chris, or mentioned about the 1,000 feet. And it's important to remember that this is a table in the National Electrical Code. So it is an electrician geared table. And most electrical cables that electricians deal with are single conductor cables, like THHN is a single conductor. So the cable is geared around circuit length, not around cable length. In fire alarm, we usually deal with cable length because we're dealing with paired cables, 18.2, 16.2, etc. This table is actually geared around circuit length. So if we have a value, for example, of 18.2, that's 500 feet out, 500 feet back for circuit length. That's a total of 1,000 feet. So we need to adjust that when we look at this table, when we consider if we're talking about a paired cable, a cable length, we need to double the number to be able to determine exactly what the circuit length, and vice versa, or the opposite, I should say. When we're talking about circuit length, we're converting it over to a cable length.
Things that I usually I point out whenever we're talking about this table is your SLC and your NACs, how many conductors are going out to the device?
Right.
And from there, there's a lot of the times people look at that and they have that understanding. Oh, explaining table is for single conductor. But what do we use? And once they pick that up, the table gets a lot easier to understand on how to use, looking at what the actual cable distance is versus the circuit distance.
Absolutely. Well, gentlemen, that concludes our time together today. I want to thank you for taking the time to join us, and I hope to see you all again soon. And for our listeners, be on the lookout for our next edition. Thank you very much.